Dear students, now we are going to discuss about Zener diode. So in the previous videos, we have discussed about the function of PN junction diode. Okay, so what is the speciality of this Zener diode? Okay, and what is this definition, symbol, construction of Zener diode and how it is working, and what is the VA characteristics of this diode and where it is applied, its application part, and then we are going to compare with the normal PN junction diode. So in this video, these are the things we are going to discuss one by one. So let us get into the video now. First part is definition. So now here I have written the definition for you. A xenodiode is a PN junction semiconductor device, okay, designed to operate in the reverse breakdown region. So this is the main part. So here I mentioned it is specially designed. Okay, it is specially designed to operate in the reverse breakdown region. So when we compare with the normal PN junction diode. Okay, so normal PN junction diode. So what is the function of this? The PN junction symbol will be like this. Okay, so when it is forward biased, the current will flow from anode to cathode. The current will flow from anode to cathode. So that time the PN junction diode conduct currents, okay, from anode to cathode. Okay, the same thing when it is reverse biased, there is no flow of current. There is no flow of current in this normal PN junction diode. That means the normal PN junction diode does not conduct current during the reverse biasing. Okay, during the reverse biasing. This is the case already we know that. This is for normal PN junction diode. Okay, but here you read once again, a Zener diode is a PN junction semiconductor device designed to operate in the reverse breakdown voltage. So this is specially designed to work under the condition of reverse breakdown voltage. So this is the main point we have to remember. Okay, it operates in the reverse breakdown voltage. That is, if you give the reverse biasing for the Zener diode, it conducts current. So this is what we have to understand. Okay, so how it conducts and how it is constructed, that part we will discuss later. So first what we have to remember is the Zener diode is a PN junction semiconductor device which is designed to operate in the reverse breakdown voltage. Okay, okay. Now I have written the symbol for normal PN junction diode. Okay, so what is the symbol for Zener diode? The symbol for Zener diode is, it is like the normal PN junction diode. Okay, here one line will be there, right, in normal PN junction, but here the symbol is represented like this, like Z symbol. That means the current flow in both the direction. In case of normal PN junction diode, already I mentioned, anode to cathode, the current flow from anode to cathode. When it happens, when it is forward biased. Okay, but during the reverse biasing, no current will flow through that. Due to the uh, increase of the width of the depletion region. Okay, due to the increasing of the width of the depletion region. But in case of this Zener diode, it works in the reverse breakdown voltage. So when it is forward bias, the current will flow from anode to cathode. Okay, so during the forward biasing, this Zener diode will act like the normal PN junction diode. This is the main point. So during forward biasing, this Zener diode is acting like a normal PN junction diode. Okay, so the current will flow from anode to cathode. Okay, but when we give the reverse biasing, that time also it conducts current. So from cathode to anode during the reverse biasing. That's what the diode symbol is, like that. Okay, this is Z symbol. So Z represents Zener. Okay, the first letter of the Zener. okay, or otherwise it represents in both the direction the current flow will be there in both the direction, that is from anode to cathode as well as cathode to anode. So this is the representation or symbol of the Zener diode. So now you have the clear idea about what is the definition, okay, and moreover what is the symbol for the Zener diode. So now definition and the symbol is over. Next we are coming to the construction part. So how it is operating in the reverse direction. So how it is constructed. So the next part is construction of Zener diode. Construction of the Zener diode. So it has to work under the reverse breakdown region. So what they are doing this, the first point is this PN junction is heavily doped. This PN junction is heavily doped. So what is the main point we have to remember? Heavily doped PN junction. Heavily doped PN junction. That is, a Zener diode is a PN junction, okay, which is heavily doped. So Zener diode is fabricated by heavily doping of both P and N sides of the junction. Actually, if you consider this, this is the PN junction. One side P type material will be there, another side N type material will be there. So the P side as well as the N type are heavily doped. So what is the meaning of doping? Doping is nothing but adding impurities. Okay. So to make P type heavy doping, in the sense we are adding the trivalent impurity more. And the same thing happens to this N type also. We are adding the pentavalent impurities more. Okay. So this is the main construction of the that is a Zener diode. Okay. So why we are doing like this means then only it can work under the reverse biasing. It can work under the reverse biasing. So that means voltage of the Zener diode is carefully set by controlling the doping level during the manufacturing. So here we are going to set the Zener voltage that we will discuss in the VI characteristics. Okay. So now the construction part is this Zener diode is heavily doped PN junction. So P type and N type are heavily doped. Okay. And then so due to this what will happen? That is what we have to understand. So due to this heavy doping, the depletion region is there, no? The depletion region, its size is, that is its width is becoming very thin. Okay. So the depletion region is very thin in case of this Zener diode due to the heavy doping, so it will be around 10 power 6 meter, less than 10 power 6 meter. So imagine how much thin it will be. Okay, so due to the heavy doping, the depletion region is becoming very very thin, which is approximately equal to less than, not equal to, less than 10 power 6 meter. Okay, and due to this the electric field of the junction, due to this the electric field of the junction is extremely high, is extremely high. Okay, so due to heavy doping, the depletion region is becoming very thin. Due to the depletion region thin, that the electric field of the junction is extremely high. For example, for the small reverse bias voltage, for small reverse bias voltage. So how much voltage we are giving? For example, 5 voltage means the electric field will be, the electric field of this junction, the electric field of the junction will be approximately 5 into 10 to the power of 6 volt per meter. Okay, so the voltage given is very small. The voltage given will be very small, but the electric field produced will be 5 into 10 to the power of 6 voltage per meter. So very high current will be, electric field will be produced near the junction. Okay, so this is the construction part. So what are the points we have to remember here? The PN junction is heavily doped to work under the reverse breakdown region. Okay, so due to this heavy doping, the depletion region becomes very thin. It is almost less than 10 power 6 meter. So due to this very thin depletion region, the electric field of the junction becoming very high, extremely high. So example I have given for the small reverse bias voltage, 5 voltage only we are giving, but the electric field produced will be greater than approximately 5 into 10 power 6 volt per meter. So this is the construction part of this Zener diode. So next we are going to discuss the working, how it is working. What is the advantage of Zener diode than the normal PN junction diode. So this is the working part. Okay, so this is the main part. So now listen. So first let me explain how the normal PN junction diode works under reverse bias. Working under reverse bias. Under reverse bias. Okay, then only we can able to understand how the Zener diode is working. Okay, so already we know that if the PN junction is connected to the reverse biasing, P type should be connected to the negative terminal of the battery and the N type should be connected to the positive terminal of the battery. So P type means here holes are the majority charge carriers and here electrons are the majority charge carriers. The holes are positively charged and electrons are negatively charged. So here negative sign, negative terminal of the battery, and this is the positive terminal of the battery. So if the voltage is given like that, what will happen? All the holes, these positive charges are attracted towards the negative terminal of the battery, and the electrons, negatively charged electrons, are attracted towards the positive terminal of the battery. So due to the reason, the depletion region width will be increased. The depletion region width will be increased, so that there is no current will flow through the circuit. No current will flow through the circuit, but a very minimum amount of current will flow through the circuit due to the minority charge carriers. Okay, so that we are not going to consider here. So this is the case of the normal PN junction under reverse bias. Okay, but here if suppose if you are giving more and more voltage here, more and more voltage here, that time what will happen means at one point that breakdown voltage at one particular voltage, the junction gets damaged. Okay, due to the breakdown voltage, the junction gets damaged. Okay, but without damaging the junction, how that current should be utilized, how the current should be utilized, so that part only we are going to discuss in case of the Zener diode. Okay, so Zener diode means Zener diode. So in this case of Zener diode, what we are doing, heavily doping. So the main part is heavily doped PN junction, heavily doped PN junction. So what will happen to the PN junction? More and more number, that means more and more number of impure atoms are added, right? So here P and here N is there. It is heavily doped. So heavily doped means here more holes will be there and here more number of electrons will be there comparatively with the normal PN junction. So that time, instead of the heavy, that means when it is connected to the reverse biasing, when it is connected to the reverse biasing, okay, instead of producing that depletion region, that means increment of the width of the depletion region, in this case very thin depletion region is created. Why? Because due to the heavy doping. So heavy doping means what will happen? More interaction will take place between the holes and the electrons. So in this depletion region, okay, in this depletion region, more ions will be there, more ions will be created. Okay, so in this case the junction is doped with the highest concentration. Because of this reason, when the reverse voltage has applied, the width of the depletion region tends to minimized. Okay, tends to minimized, but in this case it is increased, but here it is because of this heavy doping, the width of the depletion region is minimized. Okay, it is minimized. Okay, so as there exists the maximum concentration of impure atoms, okay, it creates the maximum number of ions in it. That's what I mentioned, more ions will be created due to the heavy doping. Okay, so now if you give the threshold voltage, if you give the voltage, that means we are starting from 0, 1, 2, 3, like that. Once it crosses the threshold voltage, then the current flow will be, that means the current flow will become higher. Okay, so in this case the electrons that are in the covalent bond to come out in the depletion region. Okay, so the electrons are bounded with the covalent, that bounded with the atoms with by the covalent bond. But now if we give more and more voltage, or otherwise if it crosses the threshold voltage at a particular voltage, the electrons that are in the covalent bond tend to come out in the depletion region, so that it can make depletion region conductive. So this part will become conductive. So more and more electrons will come out from the covalent bond, so that in that depletion region it can make more conductive. Okay, so now what happens? This type of breakdown is called Zener breakdown. This type of breakdown is called Zener breakdown, and at a particular voltage only it happens, right? So that particular voltage is called Zener voltage. That particular voltage is called Zener voltage. Okay, so in that means in case of the normal PN junction, already we have discussed the forward biasing. So once it crosses the threshold voltage or otherwise cut-in voltage, the current will be increasing higher. Okay, rapidly the current will be increased. The same thing we are going to discuss for the Zener diode. That means in the reverse direction. Okay, so at a particular voltage, its current will be increased rapidly. So that particular voltage is called Zener voltage or breakdown voltage. Okay, so this breakdown is called Zener breakdown. Okay, so now in this case, the value of the Zener voltage at a particular voltage only it starts increasing, the current start increasing. So the value of the Zener voltage is properly adjusted at the time of manufacturing. Okay, at the time of manufacturing by the proper concentration in doping, by the proper concentration in doping. So how much it should be doped, that during that manufacturing only they will decide, and accordingly they will adjust the concentration also. Okay, so this is the working of Zener diode. Once again I will explain, listen carefully. So normal PN junction, it will not conduct current under the reverse bias direction, reverse biasing condition, because the depletion region will be increased. Okay, that's what it does not conduct. If you further increase the voltage, it totally damages the PN junction. Okay, but in Zener diode, the PN junction is heavily doped to work under the reverse biasing condition. So due to the heavy doping, that depletion region width will be minimized. So if you increase the voltage from 0 like that, from 0, 1, 2, 3 like that, so the leakage current will be very less. But once it crosses the voltage, that is Zener voltage, okay, so here what is happening? The electron will come out from this covalent bond, and then that depletion region becomes more and more conductive. Okay, so this voltage, that means how the cut-in voltage act in the normal PN junction, like that the Zener voltage act here in the reverse direction. Okay, so this Zener voltage, the value of the Zener voltage is properly adjusted at the time of manufacturing. That is very important. At the time of manufacturing by the proper concentration in the doping. Okay, so this is what the working of the Zener diode. The same thing I would like to show in the VI characteristics. The same discussion only by means of graph I would like to show. Okay, so that is the VI characteristics of Zener diode. VI characteristics of Zener diode. So when the Zener diode is forward biased, it is acting like a normal PN junction only. Okay, so this is the voltage and this is the current. Okay, so here voltage in volts and the current in milliampere. So when we increase the voltage, so during the forward biasing, this Zener diode works like a normal PN junction diode only. Okay, so what is this? Once it reaches the cut-in voltage, then the current increases rapidly. Cut-in voltage. Okay, when it is forward biased. But the same Zener diode is connected in reverse biasing. Okay, that time it acts differently. So first what will happen when the voltage is increasing from 0, the leakage current will flow through the circuit. So here the reverse voltage, okay, so minus V, and here the current. Okay, if that when we increase the voltage 0, 1, 2 like that, the voltage, that means the current will be very saturated. That current is called leakage current or saturated current, reverse saturation current. But once it reaches the breakdown voltage, this is called breakdown voltage. Once it reaches the breakdown voltage, okay, its current will be increased rapidly. Current will be increased rapidly. So this voltage is called Zener voltage, breakdown voltage or Zener voltage. Okay, but if you use the normal PN junction diode, it damages the circuit. Okay, it damages the PN junction, but a Zener diode will not damage. It works under the reverse biasing condition. So this is the VI characteristics, and this current will known as this current is the leakage current. This current is the leakage current. Okay, so this is the voltage what we are giving is the reverse voltage, right? So this is the VI characteristics of Zener diode. And the next one is where it is used. Okay, where it is used. So for that, application. So now we are going to discuss about applications of the Zener diode. Applications of the Zener diode. So already I said it maintains the low voltage. Okay, at a particular voltage, that in that graph we have discussed, at a particular voltage it maintains the voltage, but only the current is increased. It is maintaining the voltage. So as it has the property of maintaining the low voltage even though high voltages are applied. Okay, for example, now the Zener diode voltages, Zener diode voltage what we have chosen is 5.1, 5.1 volt. Okay, so further for that, if you are increasing the voltage is from 0 0 1 2 3 like that, when it reaches 5.1, that current will be increased more. The current will be increased rapidly. Further, if you increase the voltage after 5 6 7 up to 12 also, the Zener diode will maintain the same voltage 5.1 volt only. Even though the applied voltage is 12, the Zener diode will maintain only the 5.1 volt. Okay, so due to this reason, it is mainly used in voltage regulator. It is mainly used in voltage regulator, which is nothing but stabilizers. What is the name? Stabilizers. So in our home, we will use for AC, fridge, everything. Okay, it will not damage the system, damage the device. So the stabilizer is nothing but it should maintain the particular voltage. It should maintain the particular voltage. Okay, so this is the main application of that, and it is preferably used in ammeter, voltmeter, and ohm meter, because the reference voltage is required. In this case of these 3 meters, we need the reference voltage. Okay, we need the reference voltage. So that this Zener diode is used here also. Okay, so main application is voltage regulator, that is nothing but stabilizer. Okay, and moreover it is used in ammeter, voltmeter, ohm meter because it has to maintain the reference voltage. Okay, so these are the applications of the Zener diode, right? And next, I said I am going to compare with the PN junction diode, that is normal PN junction diode, normal PN junction diode, and Zener diode, and Zener diode. So what is the comparison between them? So first one is, already I said it is working only for under forward biasing. Okay, this normal PN junction will work under forward biasing, but a Zener diode will work in both forward and reverse biasing, both forward and reverse biasing. This is the first difference. Okay, first difference. And the next one is, here the doping level will be low. Doping level is low, but here doping level is high, heavily doped, heavily doped PN junction. And then here, if we pass the reverse current, that means if we that means when it is when we apply the reverse voltage more, what will happen? The junction gets damaged. Okay, as the reverse current, okay, as the reverse current flows here, what will happen? Here the diode junction gets damaged. The diode junction gets damaged, but here it will not affect the junction. So it is conductive during that point, and then it does not affect the, it will not affect the junction under reverse biasing, under reverse biasing. Okay, it will damage, but it will not affect the junction, right? This is the main point. And the next point is, already I mentioned, the current flow from anode to cathode, only. Okay, but here in both the direction, that is anode to cathode, same thing, and vice versa, cathode to anode. Okay, so basically this PN junction used during the rectifier. Okay, the main application of this normal PN junction is rectification, and here it is used for, that is main use is stabilization, that is stabilizers are voltage regulator regulator right? So these are the comparisons between normal PN junction diode and the Zener diode, right? So I hope you understand this. So in this video, we have discussed about the Zener diode. So the Zener diode is the specially designed diode to operate under the reverse biasing, and then what is the symbol for that? Okay, how it is different from the normal PN junction, and what is the construction part of the Zener diode. So the PN junction is heavily doped to work under the reverse bias condition, and what is the working of Zener diode, and what is the VI characteristics and its application, and then finally we completed with the comparisons with the PN junction diode. Okay, so please go through this. If you have any doubt, you can ask in the comment box. So thank you everyone.